Now we're good. All right, so welcome to class on Wednesday. Halfway through the class, what I'll do is I'll give you the question of the day, and then you can type that in the comment section for those of you watching live. For those of you not watching live, watching the recording, you'll just have to email your grading teacher with that answer to the question of the day. Now, one thing is, this is your grading sections. So virtually, it means nothing to you because we submit everything online, and we as the grading teachers will take care of it. However, when we do get back here into school, then for the people watching this one live, your grading section is Wednesdays 1 through 3 with me, Linz, as your grading teacher. Okay? Whatever your Wednesday is year-long, that's going to be your grading section here in pre-calc. Okay? So today, we're going to talk about P1 and P2 out of your textbook. Again, that can be found at the beginning part of if you grabbed one downstairs last week, or if you're online, you can look through the PDF copy of it, and you can find sections P1 and P2. I can't tell you what page numbers they are in either one because they're different. The PDF page numbers are different than the hardcover book numbers are, but the problems and everything else, the sections are all still the same. So P1 is going to be talking about representing real numbers. Okay? And Mr. Roth added a nice little man, this guy goes on forever kind of a thing with pi, because remember, pi goes on forever. Oops. Yep, there we go. All right, so real numbers. Okay? Rational numbers, integers, whole numbers, natural numbers, all that fun stuff. Irrational numbers. We're just going to have a quick little chat, a little talk about them. For terms of today, if you want to take notes, this would be a great time to take notes in your pre-calculus notebook. If you say, Linz, I know this stuff, I got it, I'm fine with that. You guys are all young adults and can make those kind of decisions yourself. We will have this stuff posted online afterwards too, that if you want to go back and write something down or print off the notes or something like that, that's totally up to you also. So, however, whatever makes you better makes us better. Okay? So, I'm going to scroll, maybe. There I am. I'm going to scroll. Here we go. And then, so a real number is any number that can be written as a decimal. Okay? So if you can write it out, 1.2, 3, negative 18.147, all those are real numbers. They can be written as a decimal. Okay? Natural numbers are positive numbers, not including 0, that have no decimal or no fractional part to it. Okay? So they are integers. The positive integers are called the natural numbers. Now it gets all funky because now we got the whole numbers. The whole numbers are the positive integers including 0. So whole numbers include 0, natural numbers exclude 0. Okay? Integers then are all of the non-decimal, non-fractional parted numbers. Okay? And now it gets good. Rational and irrational numbers. So a rational number is any number that can be written as a fraction. Okay? That's what makes a rational number rational. So rational numbers could be like 9 halves. That's a rational number. It's written as a fraction. 4.5 is also a rational number because it can be written as a fraction, 9 halves. Okay? 7 is a rational number. 7 over 1, 14 over 2, 21 over 3, etc. Okay? And then irrationals. I always love giving the definition of an irrational number because the true mathematical definition of a real number is real numbers that are not rational. Okay? Which makes no sense because that's in the name. Okay? But an irrational is a number that can't be written as a fraction. So if we go back up to our little flow pie chart up here, okay? Pi is an irrational number because it can't be written as a fraction. Square root of 7, square root of 3, square root of 5, all those, funky square root ones. Those are all irrational numbers. Okay? Again, if I'm going too fast, if you're watching on the video after the fact, you can always pause, rewind, and then start again. Okay? If I am going too fast for those of you live, you're going to have to unmute yourselves and you're going to say, "Whoa, Linz, tap the brakes." Okay? All right? Let's keep going. Oops, one too many. I knew I double-clicked it. Okay? Graphing on a number line. Okay? That deals with P. So we have two different kinds of ways to say inequalities. Okay? So we have the inequality way of doing it, which is the old school greater than, less than or equal to, greater than or equal to, not equal to, those fun things. Okay? And then we have interval notation. Okay? We like interval notation because it's crisper, it's cleaner, it's much easier to see. Okay? Both of those types produce the same graph. Okay? It's just a matter of how they are written. Okay? So the first one is x is greater than 3. Okay? So in an inequality notation, it is written out x is greater than 3. No equals components, etc. In interval notation, we work things left to right. Okay? So this is telling me basically all numbers bigger than 3. Got a little delay. Okay? So in an interval notation, the smaller number goes on the left, the bigger number goes on the right. Okay? Parenthesis sides are non-including. Bracket sides are including. Okay? So parentheses give me so less than or greater than, brackets less than or equal to, greater than or equal to. Okay? Now, your textbook, because they're a book and they can print in multiple colors, your book, and sometimes in videos or things that you'll see, when you can do in multiple colors, your book would look like this. So you would have the number 3 somewhere on the line, okay? And then they would have an open circle right around it, and then they would go right over the top because they can go in different colors. Now, you, on the other hand, probably go in a single color or with pen or pencil. So for you, what we do is we put that number still on the number line, and now we go either like this, and go up and over that way, or we go, I put it as my last slide. Oh, I forgot the P2 ones, yeah. Mr. Roth just popped in again too, so we'll fix that, my slide at the end, yep. Or we go 3, and we would just go totally above the line in a single monotone color. One of those is how you probably have done it for years. Okay? So that's how we do that. Okay? Taking that to the next level, now we have x is less than or equal to 3. So now here again, this would be all numbers less than or equal to 3. So we would go now, the smaller number here would be negative infinity. Okay? And then the biggest number would be 3. So small on the left, big on the right, so we go negative infinity to 3. We have a bracket now here to go along with that 3 because we have the equals component to our inequality. Okay? Your book would have it, I got to think now, your book would have it, take some colors, would look like this, except now the circle would be filled in and the arrow would be going to the left. For us in the monotone world, or when we're producing something, we would have a filled in dot at 3, and we would go up and to the left like that, or we would have a solid dot above and then a huge arrow going to the left, or a double arrow, I should say. Okay? Oops, now I gotta scroll this way because I readjusted the screen and I went a little too far, and way off on the far side, the scrolling part is on the plastic, so I gotta fix that a little bit later on. Okay? Oops. And whoa, depth breaks. Okay? Compound inequalities. Compound inequalities have more than one. So again, we are looking for numbers bigger than 1, less than 3. So 1 and 3 are our two numbers. We're going to put them in smallest on the left, biggest on the right. 1 doesn't have an equals component, so it's an open parentheses and interval. 3 has the equals component, so it's a bracket. Okay? Your textbook would have, oops, let me put the numbers on there first. Now instead of having just one number, you're going to have two numbers, 1 and 3, and your textbook would have it like this. Okay. We would have it, or single color, unless, hey, if you want to use multiple colors, great, more power to you. Okay? But we would have it open, over, and then close, so that it looks kind of like a handle. And handle on a piece of luggage is what I always kind of say it is. Okay? So those are the 3 different kinds of inequalities. Okay? Any number at least 7. This is a different way of writing them. Okay? So any number at least. So least meaning smallest, so the smallest that number could be would be 7. Okay? So we could go x on either side, but we would have x and 7. We would want at least that is greater than or equal to. I would also accept that, either one of those, depending on which side you prefer. They both mean the same thing. Okay. That in interval notation would be a bracket of 7 going all the way to infinity. Infinity, write this down, infinity can never have a bracket. Okay? Infinity can never have a bracket. And then our graph, now let's see if I can do these with that. I can. Yahoo for school. So we've got a 7, and then we've got, that's going to be a solid dot and going that way. Okay. Love it. The question of the day. See, now you'll figure out why we put it in halfway in through. The question of the day is, are you left-handed or are you right-handed? Okay? So type in your dominant hand, left or right, in the chat, and that's your attendance for today. Are you left-handed or are you right-handed is the question of the day. Okay? Just when you thought that you could get away from doing exponents, we've got them. Okay? And for a list of rules, there is a whole, in section P1 of your book, there's all the rules. Am I going to expect you to memorize the names of the rules? By no means do I expect you to memorize the name of the rules. However, I do expect you to know them, and I kind of expect you to know them, right off the start. Like, for instance, when it's a power to a power, we multiply. When it's just a string of powers with the same base, we add them together. If it's a quotient, we subtract them. We absolutely, positively hate, and I know hate is a strong word, we absolutely and positively hate negative exponents. No negative exponents whatsoever. Okay? So in my brain, I'm thinking on like number 1 here, I'm thinking that I need to kind of do a little bit of simplification, and we're okay with simplification. Okay? So I'm thinking that this 2 right there needs to get into, it's got to go into the 3 in the exponent, it's got to go into the A, and it's got to go into the B. So 3 squared is 9. A squared is A squared. B to the 4th power, then squared, is B to the 8th power. Okay? All of that is still getting multiplied by 5a to the 6th b. Okay? Then, numbers go with numbers. So, for instance, 9 goes with 5. 9 times 5 is 45. A squared times a to the 6th is a to the 8th power, because we add those exponents. B to the 8th times b is b to the 9th. And that, ladies and gentlemen, is our final simplified answer. Okay. In number 2, I'm thinking right off the start, I don't like negative exponents. So in order to get rid of that negative exponent right here, I'm going to move it to the bottom. Or if it was on the bottom, I would move it to the top. Okay? And so what I'm going to do then is I'm going to rewrite this as a squared is left on top, a b cubed is on the bottom, and then now that b to the negative that was on top, negative 2, becomes b squared on the bottom. And now I can simplify from there. With my a's, there's one more a on the top, so I'm going to leave that one a on the top. With my b's, there's 5 of them on the bottom, so I'm going to write that as b to the 5th. So a over b to the 5th is my final answer there. Okay? Oop, didn't work. Come on now. There we go. All right. Move it all the way up. Okay? When you have a parenthesis and it is being taken to a negative power, you could do this one of 2 ways. The first way is you could say here that this is x to the negative fourth power all over 2 to the negative 2 power. You could distribute that negative 2 in to the top and in to the bottom to all the different parts. That's one way of doing it. Another way of going about and doing it the exact same way is you could say, let me reset this one, x squared all over 2 to the negative 2 power. You could get rid of that negative exponent by reciprocating what it's controlling. So I can reciprocate this right in here, and I can make that become 2 over x squared. When I reciprocate that, that negates the exponent, and then this would just be positive 2 right there. Okay? Over here, you would move this to the top, and you'd move this to the bottom, and so you'd get 2 squared over x to the 4th over here, and then that would become 2 squared is 4 over x to the 4th, and then on the other one, you would go right to that answer. Okay? Doesn't matter which way you go about doing it. Okay? A little pause for the cause. Oh, nobody was paying attention at the beginning. It's 8:32 or it's 8:31 according to my clock. 8:33 on the wall clock. And nobody said, Linz, it's 8:30. Come on now. Oh, I tell you. Huh? We have 2 things to do yet. Very easy. Okay? P2 is also what we're going to go over today. P2 deals with the coordinate system and quadrants and all that fun stuff. Just a quick recap on that. This is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And this is quadrant number 4. Okay? In this class, I will tell you that oops, now I got to move over here, that you need to know those 4 quadrants. Okay? And you need to know what order, where they are. Okay? All right? So definitely get to know those four quadrants. Okay? Two formulas that you should also get to know and just flat out know them. If we're finding the midpoint between 2 points, we take the average of the x terms, or the x parts, and the average of the y parts. Okay? And that's how we find the midpoint. Add them up, divide by 2. That's how we find the midpoint between any 2 points. For distance, we subtract the x parts, square it, subtract the y parts, square it, and then subtract those two, and then add those two together. Okay? Hold on. That should be a plus. Yes, this should be a plus in here. Yep. A squared plus b squared. Yep. That should be a plus in there, just so you know. I'll have to go back and fix that one, too. Okay? So if I'm finding the distance and the midpoint between those two, okay? So the distance, we'll go distance in green. Okay? So the distance, I would go -3 minus 1, square it. I would go 4 minus 0, and I would square it. Add those together. Take the square root. -3 minus 1 is 4. Excuse me, -4 squared. 4 minus 0 is 4. Come on now. Squared. Still square rooting. -4 squared is 16. 4 squared is 16. 16 plus 16 is the square root of 32. And then I would say, for simplification's sake, I would say that the distance here is square root of 32 is 4 square roots of 2. Because remember, the square root of 32 is the square root of 16 times the square root of 2. Square root of 16 is 4. Love it. And there is no units in this one, so we're going to leave it like that. We will do the midpoint in red. Midpoint is, I take -3 and I add it to 1, and I divide that by 2. I take 4 and I add it to 0, and I divide it by 2. And we got that. -3 plus 1 is -2. -2 divided by 2 is -1. 4 plus 0 is 4. Divided by 2 is 2. So my midpoint is that. Okay. We have some selected problems for you to do. I forgot that we were doing P2 also, so now I got to run over here. There it is. These are out of the book. Okay. EOO O means every other odd. These are practice problems. We are not going to be collecting them. They are simply for if you feel that you need some extra practice to get back into that mathematical thinking, these are for you. Okay? That's all I have for you today. If there are any questions, I will surely hang around for the next 20 minutes in the class, because that's what I'm here to do. Make sure that you have typed in the chat whether or not you're left-handed or right-handed. And those are practice problems. Now, these are, I should write this on here too. These 2 pages are hard copy textbook. They are going to be different on the PDF. On the online version, they're different page numbers. Okay? So, but the sections are still the same. So you would just do those problems out of section P1 and out of section P2. Okay? That's all I got for you. Thanks for playing along. If you have any questions, I will definitely stick around and answer them.